In this video we are going to look at four very important concepts, and it is concepts that we are all familiar with, but we can analyze it and define it mathematically, and then we're also going to solve a problem at the end of this video. So the first concept is position. Now if we look at a particle that moves around, the position is the coordinates of that particle, and in green there in the square brackets I've put the unit of measure for position. We can measure position in meters. We can write position S as a function of time. So again, if you consider a particle that moves around, that particle can have different positions at different instances in time. Position is a function of time. Then another definition that goes with position is displacement. Now displacement is basically a change in position. So how far did a particle move from one position to another? So displacement we denote by delta S, so change in position, and we can say that delta S is S prime minus S. So if you look at the blue line and a particle initially being at S and then moving to position S prime, if we take the coordinates of position S prime and we subtract from that the coordinates of position S, we get the displacement of the particle, and we also measure that in meter. Then velocity. How fast is something going? What amount of distance does a particle cover in a certain amount of time? So velocity V is ds dt. So it is a change in position over a change in time, and ds dt will give us the instantaneous velocity. We can also write that as s dot, and the dot on the s indicates that it's the first time derivative of position, and the unit for velocity is meters per second. You can also use kilometers per hour, but we are going to work with smaller velocities, lower velocities, and therefore meter per second is the SI units that we're going to use. So if you take the first time derivative of position with respect to time, you get velocity. Then the fourth concept is acceleration, A, which is dv dt. So it means it is the change in velocity over a given time period. And if you make that time period really small, if you let t go to 0, you get dv dt, that is instantaneous acceleration. We can write that as v dot, indicating that it is the first time derivative of velocity, or we can write it as s double dot, indicating that it's the second time derivative of position. And the unit is meters per second squared. So if you break that down, it is meters per second. So how much velocity change is there per unit of time? So meters per second per second. We can write acceleration in another way, and that is to say that A is dv ds multiplied by ds dt. Now ds dt, that is v, we know that is velocity. And if you look at dv ds ds dt, you can see that it actually still is dv dt, right? And because ds dt is v, we can therefore write A as v dv ds. So that's just another way to write acceleration, and it would come in handy to solve certain problems. So to summarize these concepts, if you look on the left hand side of this table in red at the top, we have S, position, is a function of time. If we go down one row, we get V, that is the first derivative of position, so velocity is ds dt. Then we take the first derivative of velocity and we get acceleration, which is then dv dt. If you want to go from the bottom to the top, that is on the right hand side of this table in blue, you can start off with the acceleration and say the acceleration is a function of time, and then integrate acceleration once, then you get velocity. So velocity is the integral of acceleration with respect to time, And if you integrate velocity, you get back to position. So S is the integral of v dt. So if you look at this table on the left hand side, moving from the top to the bottom, you differentiate. And moving from the bottom to the top on the right hand side, you integrate.